Hey guys, how is everybody doing? Today we're gonna go over implicit differentiation. This is a pretty simple topic. I'm just gonna give you an example and you're gonna get everything pretty quickly, okay? So let's start. Now let's suppose we have an equation, okay? So for instance, let's say we have 10x squared plus 2y squared is equal to 100. Okay? If we have this, now let's say if you want to take the derivative with the derivative of y with respect to x, what would you do if you have this? Well, you know that this is just simply an equation in terms of, well, you could put it in terms of x. So you have y is equal to something in terms of x. Okay, and then you would have a function that is y is equal to f of x. And then you can take f prime and you would basically get another function. But what if you wanted to take the derivative of y with respect to x without moving anything in this equation? That's where we use implicit differentiation. So first of all, let's take the derivative just with respect to y by arranging the equation first. So let's do that. So we're going to have 2y squared is equal to, move this one on this side, 100 minus 10x squared. And we can move y squared, the 2, is going to be 50 over 5, 50 minus 5 over is, 100 divided 2. This is going to be minus 5x squared, okay? Now we can take the square root on both sides and we get that y is equal to the square root of 50 minus 5x squared, okay? Now this is what I was talking about before. If you have this equation, you can just simply put it in terms of, put y in terms of x, which is what we just did right here. And now you could take the derivative of this using, the common method. So we could say that the derivative of y is equal to the derivative operator of this function, square root of 50 minus 5x squared. Okay? Now how much is this? Well, we know this is just going to be the same as if we had the derivative of this expression to the 1/2 or to the power of 0.5. And this is going to be 1/2 times the same thing, 50 minus 5x squared minus 1/2, well, exponent of minus 1/2. And we can multiply now, because remember we need to do the chain rule, by the derivative of the inside, which in this case this constant goes to 0 and we get minus 10x. Okay, this is how much we get. And now this derivative would be, let me write it right here, we would have minus 10 over 2, that's going to be negative 5x times this expression, which is going to be, this would be square root, and then we would send it to the bottom. So I'm actually going to write this as the square root of 50 minus 5x squared, okay? Now, what is all of this? Well, this is just simply the derivative for this function right there, okay? It's nothing too crazy. We just simply found this derivative. Now, what if we wanted to use implicit differentiation to find dy over dx with this equation and without arranging anything? So I'm going to use blue in this case. And I'm going to say in this here that this is going to be implicit differentiation, okay? So if you want to find dy over dx for this equation, the first thing that you're going to do is think that this term that you have right there is somehow in terms of y, okay? So you can say that y is equal to this partially. So if you wanted to take the derivative of that, well, what you would do is you would just simply move the 2 to the bottom and then you multiply by 10. That's just the power rule. So in this case, to differentiate this term, you would just simply do dy over dx of 10x squared, okay? Plus, now if we have this, you're going to do the same thing, so you're going to differentiate this term with respect to y. Okay, now this might be like weird notation, but trust me, that's kind of how you can see it. And now you can take the derivative of this constant with respect to x, which that's just going to be 0, okay? Now, you know how to do this. Now the thing is going to be in here, okay? When you take a derivative with respect to y, what you're doing to some extent is saying that, well, y is in terms of another function. So y, inside this y, there is another function. So that means that you need to use the chain rule. Okay? That is the same as if I said, let's say what? X plus 3 squared, okay? This is as if you had, for instance, y squared, where y is equal to x plus 3, okay? This is somehow like you can see it because y, you can put it in terms of x. And in this case, y, implicitly, we know, we may not see it from this equation, but just if you play with the math, you're going to find that y in this equation that we had is in terms of x somehow, okay? Implicitly, it is. So that is why we need to use the chain rule here and, well, we need to do implicit differentiation. So let's differentiate that. I'm going to keep going down here. So we know that's just going to be 20x. Now in this case, just treat y as if it was x. So you're going to have 4y times, and now what is the derivative of y with respect to the function it is in terms of? So that is just simply going to be times dy over dx, okay? Because we know y implicitly is in terms of x. And this is all going to be equal to 0 because the derivative of 100 is just going to go to 0. Now we have this. Now we wanted to find dy over dx, right? Well, we can just simply rearrange. Now, yes, you can rearrange this equation and you can find dy over dx. So you have that 4y, I'm sorry, dy over dx is going to be equal to minus 20x. And now you can move the 4y to the right. You're going to have dy over dx is equal to minus 20x over 4y, which is the same as if we had minus 5x, minus 5x, that looks kind of bad, but yeah, minus 5x over y, okay? Now there's something pretty cool right here. If you grab this, minus 5x over y, and you find how much y is, you're going to get back to when we took the derivative, using the common way. You can plug in how much. I'm going to write it. What should I erase? Actually, that works. I'm going to erase this on top. Okay. So we have some more space. Now, there is something pretty cool here. If we have minus 5x over y, you could replace y in here, and then you would get this expression in terms of x. And you know how much y is. Y is this expression. Okay, we just derived this from the equation that we had before. So what happens if you plug in y into that? Well, you're going to have minus 5x over square root of 50 minus 5x squared. And this is how much you get. And, well, you see, that's the exact same thing that we had up here. Okay? And how do we get this? Well, just using the normal derivative method. Okay? But in this case, we used implicit differentiation. We had this. Now, the tricky part, where the trick lies in is, well, knowing that, or not confusing when you have the expression in y, or well, when you have y, you need to use the chain rule. And then you can rearrange everything and you're going to get that dy over dx is some function in terms of x and y, minus 5x over y. And you know how much y is. Y is equal to this. So you get the exact same thing that you would have gotten if you had used the common method, okay? Now, this is an intuition that probably a lot of teachers, they don't go over this. And I think it's very useful to show that implicit differentiation actually has some sort of like logic, or you're not just taking the chain rule when you have y, which is what a lot of teachers might tell you. Just differentiate x, and if you see y, just do times dy over dx. Okay? That's like a more mechanistic method, and it works, but you don't really get like the notion, or you don't really get to see what happened here. Okay? Which is, well, we figure out that we have minus 5x over y, and y, well, is actually this, which is the same as this, which we got it with this method, okay? That's like very important intuition, and I hope it has been useful for you, okay? So, well, I hope you enjoyed this video, learned something, and see you in the following one. Don't forget to smash the like button.